This lesson is titled Natural Logarithms. If the base of a logarithmic function is e, then we have the natural logarithmic function. In fact, this is such a special base that we give this logarithm its own special name and actually title here. Instead of writing log base e of x, we write natural log of x, ln. Stands for natural log. Remember that you can convert a logarithmic equation to an exponential equation. Take the base to the power, e to the y, and equals x. So when we see this natural log, we have to remember the base is e to the y. Remember, logs always equal powers. E to the y equals x. Let's try this. Let's find the exact value of the natural log of e to the 5. Well, if we think of this in the other version, if we think of it as log base e of e to the 5, then it's kind of easy because we're saying e to the what is e to the 5. Well, that has to be 5. So the exact value has to be 5. This is working it out a little bit longer way, but you see we get the same result. In this example, we're going to solve for x. We're going to try to figure out what x is. So we've got the natural log of 3x plus 5 all squared equals 4. So 3x plus 5 squared equals e to the 4th. Remember, this is the base e to the 4th power equals all this stuff. If I square root both sides, I can get rid of the squared. Remember, when I square root this non-variable side, I need to get the plus and the minus. So 3x plus 5 equals plus or minus e squared. If I subtract 5 from both sides, I get negative 5 plus or minus e squared, and then divide by 3. So I get this really kind of ugly looking thing, but that's what x is. X is negative 5 plus or minus e squared over 3. Which, if we take that to a calculator, we get these two values that we can try. We should plug them back in and see if they check, or at least come out close to 4 because we're rounded off here. And I think you'll see that they do. Here's one for us to try. So go ahead and pause the video and give this a try and then check your answer. All right. Doesn't this say x equals e to the 0.1? So we just need to figure out what e to the 0.1 is. So x is approximately equal to, I'm picking up a calculator here and I'm putting e to the 0.1 into the calculator, and I get approximately 1.1052. If I want to check that, I'm going to take the natural log of 1.1052 and see if it comes out to close to 0.1. So I'm punching natural log on my calculator, 1.1052. It's not going to be exactly 0.1 because I had to round off to get here, but it should be close. It's 0.1000026. So I'll take that. I'll say that checks, and this is my answer. How'd you do? Here's another one for us to try. So this time, go ahead and pause, give that a shot. This time 3x minus 9 is equal to e to the 21. So 3x equals e to the 21 plus 9, and then we're going to divide by 3. X equals e to the 21 plus 9, all divided by 3. Let's take that to the calculator. So I'm pushing buttons on my calculator here. I'm going to go parentheses e to the 21, close off the e function with the parentheses, plus 9, close the parentheses in the numerator, and divide by 3. And I'm getting approximately, that's a pretty good size number, 43,960,524,7.8. That's about all my calculator can do, is right there. So we have got over 439 million. I'm going to try to plug this into my calculator to check. So I'm going to do natural log of, I'm just going to use the answer function there. Actually, I need to do 3 times that number I just got minus 9, close that off, see if I get something close to 21. Actually, that came out to 21 on my calculator because I used the answer function. So it plugged in, if this is rounded, which it is, it would give me more decimals in the calculator than I have here on the screen. So that's good. That checks. This has to be right. It shouldn't be wrong. Here's another one to try. go ahead and give your calculator a pause, or your computer a pause here, the video, and get out the calculator and give this one a shot. Okay, what we have here is x plus 2 over 3 equals e to the 12th. So x plus 2, if I multiply both sides by 3, equals 3e to the 12th. And then if I subtract 2, x equals 3e to the 12th minus 2. Let's get that in a calculator and see what it is. I've got 3 times e to the 12th, and then I'm going to subtract 2. I got approximately 488,262. I'm going to call that 0.4. So again, I'm going to have to take this to a calculator and give it a check and see how it is. So I put that in my calculator, and I got the natural log of 488,262.4 plus 2. Take that all divided by 3 and make sure that's all inside a natural log, and 12 does come out. So this is the answer. It has to be right. Can't be wrong. Here's another example. We're going to solve 7e to the 2x plus 2.5 equals 20. Now this is kind of tough because we have an x in the exponent, and we're not used to solving those. So let's see how we can deal with that here. Just a copy here. We just go ahead and subtract the 2.5 from both sides. Divide both sides by 7. And now, what I'd like to do is I'd like to find a way to get this x out of the exponent. And the only way I know how to do that is with logs. If I get a log involved here, then my power, remember, can come out as a multiplier in the front. So what we're going to do is we're going to take the natural log of both sides. Turns out that the natural log and e are inverse functions. They'll undo each other. So when I see the natural log with an e, the result is just going to be whatever this power is. We saw that with one of our examples earlier. Natural log of e to the 5. Remember, that just turned out being 5. The natural log and the e undid each other, and we just got 5. So here we get Here we get 2x. The natural log of e to the 2x is just 2x equals the natural log of 2.5. And divide both sides by 2. X equals the natural log of 2.5 divided by 2, which is approximately 0.458. So here's a problem that would have been pretty much impossible for us to solve except by guessing and checking before today. But now that we have logs, and we can take the log of both sides of an equation. Remember, an equation is equal, it's balanced. So whatever we do to one side, we do to the other. If we take the natural log of one side, we take the natural log of the other, and we keep it balanced. Go ahead and work that out. So natural logs, or logs in general, allow us to solve problems with x's in the exponents. You try one. Pause the video, give that a try. All right, well, I need to get this x out of the exponent, so I'm going to take the natural log of both sides right away. The natural log of e to the x plus 1 is just x plus 1. That equals the natural log of 30. If I subtract 1 from both sides, x equals the natural log of 30 minus 1. Picking up a calculator here, I've got the natural log of 30. Close off that, and then subtract 1. I get approximately 2.401. There's my answer. I could plug that in and check it out. So I could try e to the 3.401 because it's x plus 1. Let's go ahead and give that a quick try in the calculator. E to the 3.401. Close that off. And that's 29.994. Again, it's not going to be exact because I rounded. So 29.994 is pretty dang close to 30. So I'll say my answer is right. Here's another one for you to try. Go ahead and pause the video and give that a shot. All right, first thing what I would do is subtract 7.2 from both sides. So that'll give me e to the 2x over 5 equals 9.1 minus 7.2 is 1.9. Go ahead and take the natural log of both sides. So the natural log of e to the 2x over 5 is just 2x over 5. That equals the natural log of 1.9. Multiply both sides by 5. So 2x equals 5. Natural log of 1.9 and divide by 2. So x equals 5. natural log of 1.9 all divided by 2. We'll take that to a calculator and get a decimal approximation here. So I've got 5 natural log of 1.9, close the log, divide that by 2. And I punched in a wrong number there, so let me go back and edit that. I need 5 natural log of 1.9 divided by 2 is approximately 1.0605. So there's my answer. If I want to plug that in and check, I could just take 2 times the 1.605, divide that by 5, take e to that power plus 7.2, and see if I get 9.1. That's our learning target for today. I'll see you guys in class.